Let's start.
Let's get started.
Okay.
Let's go.
Only have a couple of slides to share, and then we get everything started. I cannot share, actually.
Okay, I will make you the host.
Oh, really? You have to make, I think, co-host.
You should just be able to open it up.
No, I still cannot share. But actually, Jim, you can share because I share the slides with you.
I just made you the host.
Oh, really? Okay.
So you
Oh,
should be-
perfect. Okay, so I think that Danielle's keynote plus George's comments actually make this one as a perfect pull-up for a panel. So I have, it turned out that this is a perfect group of people that answering questions that was not answered or not, not asked earlier. So we have Jim, and we have Aaron, we have Jodi, we have Michael, and we have Scotty. Now, in your HUVA, you actually have introduction of everybody. So I will leave all the time for them to answer some of the questions that I'll be asking. So I will get started immediately right now instead of spending more time on this. Okay, so I'm done sharing. So I'm gonna start asking a lot of questions. For those of you that I actually read the book, great, you probably get the answer. For those of you that are ready to read the book, you probably have a snapshot of some of the views. Okay, so I am going to ask the first question to Jim. Jim is the one that actually put together the book, and I feel there's some, all of you are contributors to the book. So I'm going to first congratulation for the book, which is very, very significant contribution. So by asking you these questions, you probably can tell more about the book, okay? So I'm gonna ask Jim the first question. Why is learning engineering needed to empower AI learning?
Okay, thanks, Dr. Hu. And before I answer that question, I want to point out that there were 28 other authors on the book. So I'm just one of the authors, and my co-editor, Janet Kolodner, had a huge role as well. So everyone gets credit. And so why is learning engineering needed to empower AI learning? Well, Danielle McNamara in the keynote kind of touched on some of this, that research is accelerating, and there are a lot of great research discoveries, but that there's still a big gap in terms of implementation of findings. Even findings from 10 or 20 years ago in the learning sciences have not yet been applied at scale in education, and new findings in machine learning and AI are not being applied very quickly at scale. And the context is that the world is changing even faster. So we have the very nature of human endeavor and work changing with augmented intelligence. And we kind of think of entering an augmented intelligence or intelligence augmentation economy that may be as disruptive as the Industrial Revolution. So with this context and the pace of research accelerating, we really need to start putting these findings into practice and implementing at scale. And learning engineering is a vehicle to do that. It can help scale implementation of these innovations and innovations in related fields like education data mining, learning analytics, and the learning sciences. And so AI in education needs this scaled implementation, and learning engineering is the vehicle to do it.
Okay, thank you. I have another question actually also follow up with what George was asking, what is learning engineering? Because the engineering term may just having some kind of, may not all positive to people that in learning, the discipline. So how do you define learning engineering anyway?
Okay, so I'll give you the concise definition. Learning engineering is a process and a practice that applies the learning sciences using human-centered engineering design methodologies, and data-informed decision-making to support learners in their development. But you don't have to take my word for it, because the largest professional technical organization in the world, IEEE, and this is the same organization that brings you the technology behind Wi-Fi, has an organization called the IC Consortium for Learning Engineering. And that is the organization that came up with this definition.
Okay. You mentioned about a process. So I want to ask Aaron, what is learning engineering process and what does it have to do with AI for learning? That's a tough question.
It's a really good question. It's a tough one. Jim, do you have the ability to pull up the slide, or do we need to switch host back?
Or is Xiangen, can you give me back the host rights and I'll...
Oh, I have to give it back. Okay, well, that's a challenge too, because I never,
Okay.
I have my Zoom, anybody can get, so let me see how.
If you bring up the participants list and the, and next to my name, there's a more button and you can.
Okay, okay, that worked, that will work. Okay, all right, make a host. Okay, here you go.
All right.
All right, so this will be a lot easier now that Jim has host skills and can put up a slide. So in the book, we put forward this image of the learning engineering process. And basically the idea is how do we take that definition and how do we operationalize it, understanding that this work is done in context and it's done with diverse sets of learners. And the work is usually done by a team, a group of people engaged in the learning engineering process, not in a single individual. And so basically the idea is in the learning engineering process, we start with a central challenge. This isn't a sort of like open-ended, throw as much spaghetti against the wall and see what sticks type of situation. We're purposely trying to address a challenge for learners or their learning or the context of which that learning happens. And in order to address that challenge, we need to engage in creation, implementation, and investigation. And it might happen in that order, or as you can see from the representation here, it might happen in different orders, depending on where you start in this process. But for the argument's sake, we start with sort of creation. So the development, the creation, the design, the building of a solution, thinking about the data instrumentation. What data do we need to collect to understand if that design is effective? If learning is happening, how do we instrument and plan for the implementation? And back to the keynote earlier, this also means we have to think about the idea of implementation at different scales, at different levels, at different sort of structures. So once you have that, you implement it, you collect data with real learners in real contexts and real situations with real complexity, and you sort of carry on to investigate. So we explore that. So to talk about that last little bit of your question, which is how does this connect with AI for learning, right? It connects in two ways. One is to think about how do we leverage the findings and innovations in AI in the investigation stage, where we've got massive amounts of data around learners and learning, and we try to use new models or methods to inform and make decisions around what we design and create for the learners. But in a sort of meta turn, we can also think of the creation and the work we do around AI as being engaged in the learning engineering process, right? If the central challenge is around understanding the complexity of the data and thinking about creating new structures, whether that be natural language processing algorithms or other pieces, if that's sort of the central challenge of building that out to do something for the learners or the learning, then it becomes an integral part of the learning engineering process and allows us to sort of engage in both collectively.
Okay, thank you. So we have a few terms over here. We have engineering, we have a process, and earlier we have like a human-centered. Jodi, I think you involved with IEEE Icicle, like an organization. So I first want you to just, some of us, audience may not know what Icicle involves. So can you explain what Icicle is? And then I will ask a question about the Icicle or something about Icicle.
Absolutely. My pleasure to share the work and the group around learning engineer that's part of IEEE. Icicle has been around for about 5 years right now. We have over 1,000 people that are part of the group. We have a monthly community call where we engage, and we also have different special interest groups to be able to talk about the different things around learning engineering. So as we've said, learning engineering is a process and a practice, and that's what we're trying to do within Icicle, is to find out how people are using learning engineering, how they're adapting it, what are they using it for, how can we improve upon it. So we're continuously looking at all the different aspects of learning engineering. As the keynote said, it's not just one area. It is about instructional design. It's about the data. It's about the infrastructure. It's about all these different ways that we're looking at how people learn with the learning sciences, with the learning analytics. So we're looking specifically at all these different areas, and we do that through these special interest groups, through design and through some tools, and through special areas with corporate and K through 12. So we're really trying to promote this as a practice and trying to build a community around it at all levels, from K through 12 to higher education, to corporate, to academics. So we welcome all of you, and we would love to see you and keep building this learning engineering community together.
Okay, thank you. So when you mentioned about engineering, made me think about the mechanical engineering, medical engineering, or now when they talk about engineering, they talk about in general, not necessarily specific for a piece of technology. For example, when you talk about mechanical engineering or learning medical engineering, they do not talk about like a functional MMI. So AI, it's so can you explain? It's a AI, in the engineering, we do not necessarily mention about specific technology. Now, this event is about AI. So can you talk about the relevance between learning engineering and AI as a specific piece of or technology in engineering?
Thank you. As we've said, to start with, learning engineering is technology agnostic. It doesn't have to be about a specific type of technology. But in this case, as we're talking about AI, we're really looking at it from the process side of things. So if we want to use AI, what is the context that we're working in? What is the problem that we're trying to solve? Who is our audience? What does the learner need? We really want to take it from that human-centered design perspective and figure out what is the use case for the AI, and then we adapt it using the learning engineering process. So it's more about the process of how you build it to make sure that this is the best learning experience that you can for the audience that you're working with. So it's really to help you think about what will work in that environment.
Okay. So from what, I thank you for clarifying. Learning engineering, it's more almost inclusive, a lot of things, instructional design, including, everything that we do. Can you make it a little bit concrete, like give it an example of typical learning engineering, work that really get people tied down to specific practice that we have?
Sure. I actually give different examples. One of the reasons to be part of this panel, I don't work in the environments that the majority of the people who are part of this group work on. I'm not an academic. I'm not a teacher. I'm an implementer who works in areas in Africa. So I've been applying learning engineering in many different ways. Part of the reason here is to show that the learning engine process isn't for one particular method of learning or one particular environment. Again, the context changes. So I'm going to branch out a little bit and expand your thinking about learning and how we think about learning engineering. I'm also not going to specifically talk about the technology. I'm going to just focus on learning and how this can be applied to learning. In Kenya, there's a lot of nomadic tribes. They do a lot of there's a lot of pastoral work, They move around their livestock to be able to get food and to get water. And there's kids that grow up in all these areas, and it's still very much a part of the Kenyan lifestyle to have these types of nomads, but these kids aren't going to school. There is actually an office in Kenya that is specifically for these nomad kids. And what happens is there's actually mobile schools. So the schools set up in different places. So here's your context, very different from what we're dealing with. Looking at the learning materials, what kind of learning materials do you need in these types of environments? What's the pedagogy that you need? And learning analytics is not just about digital data, it's also about analog data. So because there's still plenty of data that's collected on paper. So we always must think about that in addition to anything that we're doing on the digital side of things. This mobile schools have been set up to be able to accommodate these students. So they've looked at it from every point of the pedagogy and the instruction to, ensuring that data is being collected in terms of how they're learning and all these different areas. So we're really looking at the context to see what can work in these different types of environments. So that's a little bit different than your traditional answer, but just wanted to show you, again, that there's such a wide range and you can adapt it to just about any learning environment.
I think that give everybody a picture of what and how powerful learning engineering, when it's mature, and then just imagining it's going to be dramatically changing the world. Now, yeah. I want to ask Michael, you're in the industry. Given that, Icicle is 5 years in the making, and then yep. NSF instituted for this. If I ask you, what is the future of learning in 10 years, and what do you see AI playing in this? It's almost like, we yeah. look at mechanical engineering, now we have a special measure with the steam engine. So how do you see this one in this discipline or field?
Well, Dr. Hu, one of the things I certainly know, next year will be my 40th year in education. And one of the things I know is that early in my career, predictions would have been that we would move faster than we do. And yet that's not the case. And I like to say that I was an ex-chemistry teacher, and that education is one of the most buffered solutions. It is hard to change the pH. It is hard to change the nature. This is my fellow chemistry teacher up here smiling, so he can appreciate that. So 10 years is a rough horizon, but I do think we're seeing acceleration and changes in how education is taking place, and that learning engineering is going to help provide some framework and structure around that as we're thinking as a profession. And we're already seeing changes in who engages the learner in acquiring knowledge and understanding. We're seeing, at one point, you went to an institution and you did that. And increasingly, we're seeing that learners are able to seek out their own sources of information. And they're doing so in ways that are motivated by their interests and their passions and the like. And the idea of assembling knowledge from various sources is going to be one of those fundamental shifts that we're going to see happening, and we're already seeing happening. And the institutions are grappling with ways to be able to handle that. And we really need to think about the structure about how we're going to accommodate these different sources of knowledge that students, and acknowledge the fact that they're getting this knowledge from other places. The impact of learning engineering is really about this iterative process that we go through, and we make sense out of what learning is taking place. What kind of selections do we see learners making? How do educators support learners in that process? We're going to see breaking out of some of the standard, at least Western culture approaches that we've taken to learning over the last 100 years that have been sort of this mechanistic approach to really being able to address the needs as driven by individual learners. And that's going to really put stresses on the system. And our framework is really going to be around a lot of the things that we're pulling together from disparate locations within learning engineering. So I really think, is that going to happen in 10 years? Probably not. Are we seeing already the cracks in the existing systems that are going to demand that? Absolutely. I think that's happening not just for, many of us think about K-12 learners, but it's happening at the university level and lifelong learning as well, as we're looking at certifications and all those other things happening. So it's going to be pervasive in our society. I am going to answer another question that you would ask Jodi actually about Icicle. And I just wanted to make sure that people were clear that Icicle really, although we have a community meeting once a month, we also have these special interest groups and our market interest groups. And the real work of Icicle, if you really want to get down and dirty around learning engineering, you should really join one or more of those SIGs or MIGs. And those include, and I just have a cheat sheet over here, higher ed, students and grads SIG, the competencies, credentials, and curriculum SIG, design SIG, the corporate market interest group, the K-12 market interest group, and the tools and implementation SIG. So it's those kind of, find your community if you really want to understand more about learning engineering. So yeah, back to you.
Okay, thank you. So this is great. You know, I can imagine that every one of us, including 100 plus participants, we all probably previously are implicit product of learning engineering. So in the next 10 years, we're going to be labeled, we are the product of this engineering process of learning or education, right? So in other words, there are a lot of factors, factors that actually influence this. Now, I want to ask Scotty. Now let's look at what we have learning engineering. Every individual, every learner is a participant. Of course, researchers. Now, Scotty, yourself was a psychologist. Now you're in the engineering school. So you certainly have a very good take of who should be involved if we use AI empowered learning solutions. In this extremely powerful the discipline. So who should be involved?
Thank you, Xiangen. Yeah, as you said, my kind of degree and my background is kind of interesting in that my original degree was as a cognitive psychologist. Now I'm an engineer in engineering school. I'm also in the Mary Lou Fulton Teachers College. So I'm actually at that weird intersection of all three. But even then, I can call myself a learning engineer. But that doesn't mean that I do everything, because not everybody can do everything. We really have to think that we are actually more of specialists in specific areas of learning engineering. And there are a lot of them. Some of them have been identified. Actually, Jim, could you go ahead and share the screen again for slide number 19, I believe? Because learning engineering itself, yes, if you think about the AI aspects, the AI aspects are heavily involved in learning engineering with software engineers and computer scientists, and also data scientists. So those are, oh, actually, maybe your number is different than my number of 18. There it is, right there. It was 29. Could you go back up one? 29, thank you. So there is a wide spread, as you can see here, and this doesn't even incorporate everybody. So there's areas such as learning sciences, which really encompasses all of the social sciences. Anthropology could be a big deal into this, for example. Also, when we get into the data science, software engineering, as I said, even that can be expanded because really computer science is in there, and a lot of the expanded areas that touch on AI and education would be fit within this area also. And we also have to think about the design sciences or the user sciences. So learner experience design, learning environment engineering also fit there, but also UX, the broader UX area, and areas such as my area that I'm in, human systems engineering, also fits in that wider array also. But I think also what you have here in this panel is actually a good example. And I'm actually very glad that, like Jodi, when you started actually talking about your applied example, you're like, I don't fit in, I'm different. And there you have learning engineering. A lot of us are like we are trained in other areas and we come in and we're looking at this from these unique perspectives. And contributing our unique knowledge to this area to really solve problems. So yeah, who should be involved? As you noticed, I was very, very broad because the answer is very broad and we have to think broad and we can't actually put up barriers. We can't put up walls to keep people out because you never know whose perspective is going to be needed to solve a specific problem. And if any of my other panelists have something to add, please.
Yeah, I will just add that what's important is to recognize that people are coming from different perspectives, and that's really why shared understanding is needed, because in some of these domains, the same word can be used for completely different things, and we can't have people talking past each other and effectively solving problems. So having some cross training and understanding just a little bit about everyone else's domain is really valuable. And even if the team is made up of people and no one on the team is called a learning engineer, the team can still be doing learning engineering.
Scotty, I'm going to take advantage of your invite there, and that is that we had our first Icicle Learning Engineering Conference in 2019. And what was wonderful is my background's in K12, but I do work in workforce development and the like. But there were people there from petroleum, there were people there from aircraft manufacturers, and it really helped me be clearer about sort of thinking out of my normal manner about applying learning engineering by hearing it being used in other areas. And so a shameless plug is that our next conference is 2023, July 24th through 26th. At CMU, and I certainly would invite everybody to take advantage of that as an opportunity to interact with people outside of your immediate area and learn more about yourself that way too.
Yeah, thank you, Scott. I think this one of the when I was mentioning learning engineering to our own university, University of Memphis, somebody immediately jumped out. You want to have another engineering school? Right, because they certainly feel like a threat or feel like, okay, that's my territory. You guys, So in other words, there are a lot of explanation to do. So I want to ask Aaron. You are from Boston, MIT. You probably ask questions all the time. People. If I'm going to ask you this question, what is the difference between learning sciences and the learning engineering? Because maybe you have a very crisp answer, but that's actually answer that the question bugs me a lot.
Yeah, and I think so. Part of it, I'll go back to the keynote, which is this idea of sort of what the purpose of the work is, right? So for most of the learning sciences, they're working to build core knowledge and understanding around certain theories of learning, and sort of exploring and doing sort of the research and the work associated with implementing those types of scaled or not scaled approaches to research, right? And they sort of are the core practices and principles of the sciences. The analogy holds for what's the difference between a chemist and a chemical engineer? What's the difference between a sort of physicist and a mechanical engineer who applies those physical principles, right? The same kind of holds here, right? You've got learning scientists who are exploring the sort of natural phenomena of understanding the core of what is learning. And then there are learning engineers and teams, as we've discussed just now, who bring together other ideas, including understanding of context, understanding of other domain areas that impact the learning, right? So, one of the things that I think really struck me about the keynote was the idea of most of the learning sciences research focuses on a single perspective on learning theory, and either trying to prove or disprove a part of that. I thought that was a really key point in the last session, and I want to carry it forward to say, learning engineering is trying to bring as broad a perspective in addressing those central challenges of learners and learning that may be slightly different from what the work of specific learning sciences folks are doing.
Oh, thanks, Aaron. This actually, I'm going to ask you another question, because when Jim was showing the picture, you have the sheer understanding. You actually listed quite a few disciplines. Learning science is one of them, and another thing is another one of them is learning analytics. So now, if you want, I'm sure that in your book, the toolkit, you probably have a lot, good picture. So if you describe learning engineering almost like a discipline, and then the inside there are quite a few things. I can pick up anything that I want you to address with their relations. I want to have a specific one. Is learning and learning analytics. What is the role of learning analytics in engineering, and how to take advantage of learning analytics in learning engineering? Jim.
Want me to take that? Sure. And so before I do that, I'm going to share an image and just kind of segue from Aaron's answer. So this is a model of a controlled loop control system. And this is very relevant to learning engineering because an open loop control system is you have inputs and a process and an output, but you don't have feedback. And so engineering control theory is important for learning engineering, both as a learning engineering process, but also borrowing some terms from engineering, like transfer function, the difference between the inputs and the outputs, and propagation delay. What kind of feedback do we give in the system, and how long does it take to impact the system? And this feedback loop can apply to the learning engineering process, but it also applies to learning. So if we have inputs as instruction and context around the instruction and the environment in which a learner is learning, and the process is the learning, and there are outputs, we're measuring performance. Knowing something about those outputs can be immediate feedback to the learner in terms of, such as an intelligent tutoring system that gives immediate feedback, or it could be broad scale feedback. What course should the learner take next? Or what career, what's the trajectory towards a new career? So at multiple levels, this engineering concept can be applied. So now let me get to the data question. And so in learning engineering, at least in the toolkit, we broke down data into two parts. Step one is getting the data, and we use a fancy word for that, instrumentation. And instrumentation could look something like this. On the left, we have devices, hardware that's capturing things like clicks and taps of the learner. But that's not good enough. There are standards for capturing that data, but we also need hardware sensors that can wrap that data with some contextual elements, like who tapped or clicked, and what activity were they doing, and what are some of the context variables. Ideally, the more we can know about the context in which a learner is doing something, the better feedback we can provide. And then those data move along a data pipeline and are transformed for different purposes, whether it be for research or for analytics that helps us determine how to iterate on the solution, or it could be for immediate feedback to the learner. So that's the instrumentation side of things. And then we are concerned about using the data, how we're going to use the data. And the fancy word used for that is learning analytics. So I love this example from Duolingo that they're using machine learning to really address a century-old learning sciences finding from Hermann Ebbinghaus about forgetting curves. And we know from more recent research that the best time to practice, retrieval practice, is right before you forget a word if you're trying to learn a new language. And so Duolingo has something called the space repetition, trainable space repetition model that uses some machine learning with millions of learners. And your specific trajectory through the learning experience to predict your future when you're going to forget a word, and then introduce it just at the right time, which is right before you forget it. So in the book, we have a learning analytics process model that Steve Ritter and I developed based on Ryan Baker's massive open online textbook. And well, let me walk you through this. So it starts with, what questions do we want to answer with the data? And if we don't have the data we need to answer the question, then we need to develop some instrumentation. And if we do, we need to translate the operational question into a data question. So if the real world question is which students need intervention, we might need to break that down into more than one data question, such as how do I predict the probability and what is the cutoff for intervention? And then we have different methods that we can use that are established in the learning analytics community. Whether we're doing predictive modeling or inference modeling, are we trying to determine which learners should get an intervention? Well, we need to understand not just the likelihood that an individual learner might need an intervention. We also need to understand that there are resource constraints. We can't give the intervention to every learner. And so we need to set some thresholds of which learners, and that kind of gets into classification. We can infer knowledge if we want to predict whether the learner will get the next answer correct, or we can do some behavior detection, such as is the learner bored, or is the learner engaging in an off-task behavior. We can do some visualization like learning curve analysis that gives us insights into whether there's something wrong with the system of learning that we're delivering. And I'll put up this slide. If you wanted to scan the QR code, there's a page from Learning Engineering Toolkit with this process model in it.
Okay.
I probably more than answered the question. So
well, actually, this one lead to another very sensitive question. So learning analytics is actually, it's so powerful, getting to be scary, right? Because think about that. You actually earlier in the keynote, someone asked questions, say, how do you protect the learner? So now you're looking at just imagine that you're in the hospital, you get the blood samples or the data of every patient. That's just another field. Actually, people started asking very, very critical questions about ethics. Okay, so the question also again to you, Jim, you can answer. Any one of those questions we could revisit after we have, we should have a few minutes time. So, in other fields like medical or even right now in social, there are a lot of ethic issues, and the AI actually advanced. So can we use, or should we use, or eventually going to be how, use advances from other domains? Like a big data, you have learning analytics, they can be biased. What happens if you have one formula that predicts the entire generation on the wrong track? That's just, it's almost like a disease if you think about it. So how can learning, how can advances in AI for business, we learn from them, apply to learning? So that's a very, very important question. So maybe at the end, we're going to have a discussion on this. Okay, you give it first a shot.
I'll give it a shot. So yes, big data can be messy, but we definitely should be learning from these other areas that are recognizing that there are biases. And there are standards groups within the IEEE that are looking at explainable AI and looking at ethical AI and how to overcome some of the problems that other domains are discovering. And yes, it can be imprecise, in bias, but does that mean we don't try to help learners with it? No, we should still be working to use what we can while we're also trying to solve the problems of bias and so one really important aspect of the learning engineering mindset or engineering mindset in general compared to other domains, we don't want to throw out the outlier data. We want to focus on the outliers. And that's kind of, if you think of physics versus aeronautical engineering, a physicist might be interested in generally the physics of flight and might throw out some outlier data, but an aeronautical engineer wants to focus on the outlier data to know how specific conditions might cause a specific kind of aircraft to crash and solve those problems in the engineering design.
This is a question that we're going to come back to discuss, because I do remember that I have a car, and then occasionally they come back and recall parts because they probably made some mistake or have some oversight on the engineering process. Can we recall learning engineering products? Say, for those group of students, now whatever you learn, you need to relearn. No, that's not possible. So in other words, in learning engineering, we may be especially care on those, because any product that we produce are the human. You cannot recall them. The things you cannot recall. So that's something that certainly worthy of discussion. But we're going to go through this. We're going to take a long time to talk about this. But I tried to make at least 10 minutes for our discussion. So I have a question for Scotty, because you're at the university and you probably mentoring students. You convince the people coming into to learning engineering, given this is such a promising field. How does someone pursue learning engineering as part of their profession?
Thank you for that question. There's two things that I want to kind of start out with saying with that. One important thing, as we've said, there's not really you can be a learning engineer, but you're not really going to be trained in all of learning engineering. Now, there are some programs out there that are learning engineering programs, such as a master's of learning engineering at Boston College, which tries to give overall pictures. But in general, what you're going to be coming from and the training you're going to get is in these specific areas that we talked about earlier, and sometimes in interdisciplinary areas. Just for example, within my program of human systems engineering, we have a master's degree that's human systems engineering with a concentration in intelligent systems. And that brings in the AI, the human systems, the psychology part, and some of the data analytics to build, and software engineering to build these systems and test them. There are other things that we have coming up, such as a master's in data science with a human-centered focus. So these are areas where you can actually start combining these two areas. But really, what you are doing is getting training in these specific areas so you can actually function as these teams. That's why I think that one thing that's going to be really useful is actually going to be certificates, where you take disciplinary areas and you train them in the general ideas of learning engineering. And that's one thing Danielle McNamara in her keynote, mentioned some of the initiatives that are going to be put forth in the new Learning Engineering Institute. And one of them will be a certificate program, where it'll be a certificate in learning engineering that goes along with these other disciplinary programs. Now, we can do that connected to degree programs, but you can also do that connected to professional training programs. So it doesn't have to be specifically connected to the university. And ASU does things like that too. And I'm sure the Institute, the Learning Engineering Institute here at ASU will be looking towards that also. And our Knowledge Enterprise, where we'll have professional certificates also. And I want to kind of shift this over and give Aaron a chance to talk about it if you want to, Aaron, because I believe CMU, where you have one of these types of certificates already, don't you?
Aaron?
Yeah, so
Sorry, I was trying to find. So yeah, so at CMU they do, right? So the Metals program has Masters of Learning Science, Applied Learning Sciences, right? So and part of their part of that program also offers certificates in various aspects of the program as well. So yeah, there's a couple other floating around as well. And I think one of the key pieces, and Scotty mentioned it before with the program at BC, and we've been lucky to hire somebody at MIT who graduated from that program. And I just to sort of put a fine point on what Scotty mentioned, like it's that general understanding of where the crossovers are. It's knowing when I go to my team member who is the expert in learning analytics, or when I need to bring in somebody from this area to ask the right questions about, you know, design or interface or these other pieces. And so I think that's all a big part of the pieces along the way.
Thank you, Scotty. I think I always be entertained with an idea of knowledge supply chain or learning logistics. Basically, in a supply chain, for example, if you're building cars, you do not have to build an entire car to be in the automotive industry. You can just build a wheel, and you are contributing to the entire supply chain. And the similar, I think, is in learning engineering or knowledge supply chain from this. So I think that's good. So in other words, the conclusion, at least the consensus, everybody can be part of this learning engineering your profession. So now the last question before we discuss, I want to ask Michael. So you're the IEEE Icicle chair. Since anybody can be either a product of learning engineering or
Yep.
You're part of production as a professional learning engineer. How can people involved with Icicle? Because I think this, although this is an AI conference, but I think this is very, very crucial or very, very important for people to know what to do next, because the time goes very, very fast. If we do not want to jump on the bandwagon, we get left behind.
So thanks for that. Jodi posted actually the link to the listserv if you want to join the Icicle listserv and get involved. As I mentioned earlier, getting involved in the special interest groups and the market interest groups within Icicle is really where the heart of the work gets done. And we were talking in our planning and actually would be open. You notice I did not list a SIG built around AI. But there's no reason why there couldn't be a SIG built around AI, and take a look at some of the common elements that some of the other SIGs and MIGs are looking at as well, but with an AI perspective, with a focus on that, and then begin to integrate that into our other discussions around learning engineering. It exists in a lot of our discussions already, but it hasn't been a focus of conversation in quite that way. So I know, Aaron, you had some other ideas when we were talking.
I did. No. Sorry. Yeah, I mean, so I also think there's the big idea of sort of the SIG, but then there's also the ideas of how might we integrate these pieces into other parts of the process or the work that's already going. So for example, thinking about in our tool SIG, which really focuses on instrumentation, thinking about, and with colleagues in this group, about how we think about applying the most recent findings in sort of AI and learner and NLP and these other pieces to be able to make better decisions and implement them. So how do we inform the community and keep the community informed of these new results and ideas and pieces so that they might actually take them up in their work, so that it's not just the academic pursuit, but it is in fact the sort of pursuit of supporting the learners. And so, being a place where people may come share their ideas, their knowledge, their expertise with the community as a way of broadening and spreading the sort of ability of the overall group.
Yeah. I would also, just to add that I tell people when they join and get involved with Icicle to be selfish. Bring the problems that you're grappling with in your professional life to that community, and you suddenly have a team that you can discuss some of those with, either in a veiled fashion or overtly. But it's a wonderful place to get some really bright people and get their thoughts and really create some new colleagues who really understand the sort of systemic approach that's being taken here.
Thank you, Michael. We successfully left 10 minutes for burning questions for everybody. So if you open the chat, by the way, in your Wova, they actually link LinkedIn and Facebook of everybody. So feel free to be friend with, for example, Icicle chair. Just ask questions. We won't be able to cover. We won't be able to solve the world, save the world in an hour. So we're gonna entertain some of the questions here. So can Jim be the one that actually pointing to the questions and then sign people to answer?
Go ahead,
Jim, do we
Aaron.
want to start? Yeah. So one of the questions that we got, which I think is really great, is this idea of ethics, right? So the aspects of ethics and governance, especially of AI. I'm sure that will be a major part of discussion over the coming days, and sort of like how do we establish governance and processes and practices over these things. So in the book, we talk about learning engineering being ethical and engaging in the ethical practice. And one of the things that I think is important about that representation, it's meant to be concurrent. So one of the things that I think is often a challenge as we think about processes is it's often like, well, I do my part and then I hand it off to the next person, right? Like, well, I'm the data scientist and you're the ethics person, or I'm the data scientist and you're the instructional designer. And so you do this over here and I do this over here, and they're very separate, right? So when we think about this idea of ethics and learning engineering, and especially in this AI piece, it needs to be a holistic conversation. It needs to be part of what the team is considering from the start. Once you've established what that central challenge is, considering the ethics challenges that may arise, and maybe even the unintended consequences of some of the results that come out, are pieces that need to be talked about in the team and part of what is sort of put forward as a solution to the learning challenge. So I think the answer is it is part of the conversation, and it needs to be part of the conversation, along the way, not sort of a secondary thought or an afterthought as part of the conversation.
Yeah, it's a change in mindset from trying to understand the entirety of the problem and do a one-off and be done, to iterating on the problem and iterating on the solution. Jodi, did you have something?
No, I just wanted to share some of the questions that we included and thought about it. Once again, in the book, we have an evaluation matrix for ethical design. So just to give you an idea of some of the questions that we are been asking, and I'm sure we have learned a lot from all of you with your expertise. But as Jim and Aaron said, it's really much more holistic approach. One of the areas is about fidelity and responsibility. So it's talking about promoting trust. It's talking about the local regulations. It's talking about if the stakeholders have been consulted, does it apply with codes? Another area is about the integrity. Is there any, what are the people who are working on it? Are there any errors or biases? Another area is about benevolence. So what are those harms and those benefits? And the fourth area is justice. We really spend a lot of time about equity and justice. And the last area is about respect for people's rights and dignity. So it is a very comprehensive way we are looking at ethics. And we look forward to continuing that conversation with you.
Thanks, Jodi. And Nadia asked about frameworks. Well, we have different kinds of frameworks. Michael mentioned in the chat that we're currently working on a competency framework for learning engineering in the competency, credentials, and curriculum SIG. So please join us there. We also have framework. You saw the analytics kind of framework. We also have other kinds of frameworks beyond the ethics framework. We have we start to unpack the idea of design patterns, and this comes from different areas of engineering. So if you're a civil engineer in building a bridge, there are patterns like a suspension bridge, but not every suspension bridge is the same, because the requirements for the span and the soil conditions and the weather conditions are all different. So just like learning, every learner is different. But we can draw from some common design patterns. And this is kind of a new field. We are just starting to develop some of this, but I think there's a real future where we can accelerate the scale of impact from learning engineering by further developing these design patterns. Let's see what other questions we have in the chat. And feel
I'll
free
take, well, Jim, you keep reading. I'll jump on one that Krista Morrison wrote, which is, do you have any thoughts about professional development of educators, K-12 and higher ed, given the application of not only learning sciences, but data AI? And yeah, right. So I think this goes back to what sort of Scotty was mentioning earlier, which is this idea of like, you know, building out the sort of understanding of various professions, including K-12 teachers and higher ed groups. It's a special area of interest to me. My background is in science education and teacher preparation. So that's part of my shtick as well. And I can tell you, like, it's something I've thought a good deal about, because I do think that one of the things that is part of the team in K-12 is the teachers, and also subject matter experts, and also curriculum writers, and and it's also stratified within the classroom and the school and the school community and all of these other pieces. And so taking into account the sort of different levels of which engagement is necessary becomes a real important part of how we sort of build out the ability of groups to engage in this work. Scotty, you have any? I'm sure you got a follow up on that one.
I do have a follow up on that one. I wanted to make a call back to Danielle's keynote. When you actually noticed, it's one of her slides. One of the main purposes of this new institute is going to be reaching out to K-12 teachers and administration to help integrate learning engineering, especially within the state of Arizona, into that, and actually increase knowledge of it and application. So yes, in a lot of ways in which you have to do that are through these basically workshops, professional development, and certificates.
Okay, we have 2 minutes. I want to thank the panelists, and also great questions that actually been posted over there. And then I noticed that this is recorded, and then now you know everybody's face. Feel free to get in touch with everybody, and do learning engineering. Okay, let's make this one as a slogan. Okay, again, thank you very much, and then just go to another session, because every one of the sessional panels are very, very, very good. And then thank you very much.
Thank you.
Okay.
Thank you
Bye.
all.
Yes, thank
Thanks,
you everyone for
everyone.
coming, and thank you,
Bye.
Xiangen, for hosting us today.
Yes.
Yeah,
problem.
absolutely.
Dr. Who. It's awesome.
Okay. Bye.
Okay, bye, everybody. Stay in touch.
Yeah.
Yes.
Definitely.